Hey guys, welcome to ANS Solver. Today we'll be doing the concept of the R sin alpha plus beta and R cos alpha plus beta form. Okay, which is a subtopic in the chapter of trigonometry. Okay, so this is basically just one type of question which is normally asked. It totally, is a process based concept. Okay, so we'll be doing this concept via an example. Okay, so basically the example is they'll ask you something like express root 3 sine x plus cos x in the r sine x plus alpha form. And they'll let's say specify that alpha needs to be between 0 degrees and 90 degrees. So what you basically need to do is the first step, okay, note down the steps, is first write the form which is r sine x plus alpha. Now, as you can see here, you have sine x plus alpha, which is the sine compound angle formula, correct? So you can write this as r multiplied to sine x, correct, cos alpha, correct, plus cos x sine alpha, correct? Okay, so normally you only get these kind of compound angle formulas. Here you have sine, sometimes you get cos, correct? So it's like 99% of the times it's always a compound angle formula. The next step you do is take r inside the bracket. So you simply get r sine x cos alpha plus r cos x sine alpha, correct? This is what you basically get. So now comes the very important step, which is called as comparison. Okay, so basically you have a sin x here and a sin x here, correct? Because you need to express it into the correct form, so you need to compare. So you have a sin x here and a sin x here. What is sin x multiplied? Okay, 2 here. It's basically multiplied to r cos alpha, correct? If you see the sin x here, it's multiplied to r cos alpha, and the sin x here is multiplied to root 3. So you simply equate them. So you equate r cos alpha to root 3 because those are the coefficients, correct? In the same way, you have a cos here and you have a cos here. So you simply write r sine alpha. So you write r sine alpha, which is equal to the coefficient of cos x here, which is nothing, so you can take it as 1. Okay, so another point to note is mostly the signs which you get here, okay, are always same, so you don't need to worry about it. So now you can write this as cos alpha, which is equal to root 3 over r, and sine alpha, which is equal to 1 over r, correct? This is what you get. You get two equations, one in cos, one in sine. So the next step is really important. You basically draw a right angle triangle, correct? So your right angle triangle, okay, let's say looks something like this. Okay, this is what you basically get. So let's say I have this is the 90 degree. I'll just draw this line, okay, in a better way. Yeah, okay, so this is a right angle triangle. Let's see the angle here which you have, because there's alpha here and alpha here. Okay, the angle which you have here is alpha, correct? This is what you basically get. So now you need to know that cos is adjacent over hypotenuse. So the adjacent of alpha is basically here. So I'll have root 3, and in the hypotenuse I'll have r. In the same way, sine, okay, is opposite over hypotenuse. So the opposite is basically 1, and the hypotenuse is basically r, correct? So I can simply now calculate r, where I know that my r square is equal to 1 square plus root 3 the whole square, correct? Simple Pythagoras theorem. So I can write my r basically as the root of 1 square plus the square of root 3, correct? So I can write my r basically as the square root of 1 plus 3. So I get r basically as the root of 4, which gives me my r as 2. This is what I get my r as. Now what you need to do is you need to calculate alpha. So for that, just to be safe, okay, you take, if you take cos alpha or sin alpha, it's perfectly all right. But just to be safe, if you have a sign here, take the sin alpha equation. So you can write this as sin alpha, which is equal to 1 over r. Now I know I can write this as sin alpha, which is equal to 1 over 2, because I know r is 2, correct? So now make sure you're in the degree mode, because you have degree. So you simply just need to do shift mode and 3. So now you get alpha, which is equal to the sine inverse of half, correct? So the sine inverse of half is basically 30 degrees, which is basically the alpha value. So now you have your r and you have your alpha. So you can write it in the form which I have given is r sine x plus alpha, correct? So you can simply write this as r is 2. So you can write this as 2 sine x plus 30, correct? So this is basically the final answer which you basically get. So this is basically the full process. Let's go over it once again. So normally, they'll ask you to express this into r sine or cos, x plus alpha formula. Okay, so basically it's always a compound angle formula. So you write the compound angle formula here, take r inside, then you simply compare them, correct? And then you get two equations, cos and sine, correct? Then you make the right angle triangle and plot them. Okay, probably label the sides, okay, and the angle. You calculate r using Pythagoras theorem. Once you have r, you basically take one of these equations. You can actually take any, but just to be safe, just to be on the safe side, see if you have a sine or cos here and take the respective equation. Then you can calculate alpha and then write it in the final form. Now let's do a past paper example, correct? So this past paper example is basically from 2017 Feb March paper 32. Okay, so I need to express, I have 8 cos theta minus 15 sin theta. Okay, so this is basically the cos formula here. I need to express this into the r cos theta plus alpha form. Okay, the r should be exact and alpha should be the 2 decimal places. So the first step, the cos compound angle formula. So I can write this as r multiplied to cos theta cos alpha minus sin theta sin alpha. So now I can take r inside the bracket. So I can write this as r cos theta cos alpha minus r sin theta sin alpha, correct? This is what I can simply write this as. Now I compare. I have cos theta here. I equate the coefficients. So I have r cos alpha, which I equate to 8 here, correct? And now you simply have r sin alpha, which I equate to 15. Okay, so I have r sin alpha, which I equate to 15. I told you mostly the signs, okay, are same. So I equate to 15, not minus 15, because the signs are same, correct? So now I can simply write this as cos alpha, which is equal to 8 over r, and sin alpha, which is equal to 15 over r, correct? This is what I simply get. So now I can make my right angle triangle here, correct? So I get something like this, correct? And this is a right angle triangle. I have alpha here, correct? So now I have cos alpha. Cos is adjacent over hypotenuse. So the adjacent is 8, the hypotenuse is r, and sine is opposite over hypotenuse, so I get my opposite as 15. So I get my r basically equal to the square root basically of 15 square plus 8 square. So I get my r basically as 15 square, okay, which I can simply do on the calci. 15 square is 225, okay, plus 64, which gives me my r basically as the root of 225 plus 64, which is basically 17. So this is my r, correct? So now as you can see, I have a cos here, so I take the cos equation, so I write this as cos alpha, which is equal to 8 over 17. So now I have degrees here, so I do the I'm on the degree mode, shift mode and 3, correct? Then I simply do alpha, which is equal to the cos inverse of 8 over 17, which I basically get as 61.93 degrees to 2 decimal places as mentioned in the question. So my final form is basically 17 cos theta plus 61.93 degrees. Correct? This is the form which I needed to maintain in the question. So this is my answer. So this is the basic concept which you need to know. But mostly in these kind of questions, they ask another part, okay, which is, simple trigonometry where you need to calculate, the value basically. So let's have a look, on those kind of questions. So this is the second part. So I need to solve the equation 8 cos 2x minus 15 sin 2x, which is equal to 4. Now, if you notice properly here, I had a theta here, correct? But here I have a 2x. Now I know this theta form here can be written as something like this. That means if theta, okay, is replaced by 2x, the theta here will also be replaced by 2x. So I can simply just write this as 17 cos, instead of theta I can write 2x plus 61.93 degrees, which is equal to 4. Correct? This is what I get. My domain is 0 degrees to 180 degrees. So shift mode 3 for the degree mode. Correct? Now what I can do is I can simply write this as cos 2x plus 61.93, which is equal to 4 over 17. This is what I get. Now I need my cos to be positive. If you know, in my ASTC, my cos is positive in the first quadrant and the last quadrant. So if this is theta, this will be 360 minus theta. 360 because of the degree mode. So now what I basically do is I write this as 2x plus 61.93 degrees, which is equal to the cos inverse first of 4 over 17 to get the value in the first quadrant, which is basically 76.391 degrees, comma, now I do 360 minus this value 76.391 to basically get 283.609 degrees. Now I can write this as 2x, which is equal to 76.391 minus 61.93, comma, 283.609 minus 61.93. Correct? So I can write this as 2x, which is equal to 14.461, comma, 221.679. Now I can write my x. Basically I can divide 2 by each of these values. Correct? So I'll just write it for you so that there's no confusion. So I'll get 14.461 divided by 2, comma, 221.679 divided by 2. correct? So I get my x here basically as 7.2 degrees, comma 110.8 degrees, which is basically the final answer, correct? So generally with the r sine alpha plus beta or cos alpha plus beta form, you get a follow-up question something like this where you need to solve. Okay, mostly in most questions they ask it like this. Okay, so with this we come to an end with the chapter of trigonometry. Okay, so basically this chapter is really very important, not only for this individual questions but even in the further chapters like differentiation, integration, which we learn okay ahead. Okay, it's really important to have a trigonometry strong. Okay, so only knowing the concepts won't help. Okay, you need to do the topic wise questions very thoroughly, and if you get stuck, okay, you can view the video solutions and pictorial solutions which we provide, okay, in detail. Okay, and you can be totally doubt free and you can master this chapter totally. Okay, and once you're done you can move on to the next chapter. Okay, so thank you for watching. Okay, so yeah.